probably seen rational functions before, probably worked with them with algebra and graphed them and all sorts, but you may not be familiar with this phrase end behavior with a rational function. I'm sure you've seen it, but we usually call it something different. We call it an asymptote. Right? These are asymptotes. They're horizontal or they're oblique or slanted, diagonal. There's some kind of asymptote, but that dotted line that goes across your graph, that's what this question is asking about with this infinity notation here. It's saying what's happening as x goes all the way to the left and all the way to the right. That's an asymptote right there. So the question is, what kind of asymptotes are we dealing with? And what I want you to focus on is the power function of the numerator and the power function of the denominator of this first problem. So if you look right here, what do we have here? We have basically x cubed times x, which means overall, the power function on the top is going to be some kind of an x to the fifth. Now, of course, there's other stuff, right? This is complicated, and you could spend some time multiplying that all out, but the power function is the driving behavior of this thing, and that's what I want to focus on. So x to the fifth, and on the bottom, we have x to the sixth of some kind, right? It's 5x to the sixth, but what this means is this guy is bottom heavy. And if you remember what bottom heavy means, that is a horizontal asymptote at y equals 0. Okay, so when we write the limit behavior, we say, what's g of x approaching? In other words, this thing right here, that's the y value. Okay, that's the y value, and in the parentheses is the x value. The y value is approaching the asymptote. So we just say 0. Now let's move over to the next one. Same idea, but this one has different function behavior because on top we have what looks like an x to the fifth, just like in the previous one, and on the bottom also an x to the fifth. So these are now equal weight. It's not bottom heavy. And with equal weight, if you remember, we also have a horizontal asymptote, but this one is located at a ratio of the coefficients, or the leading coefficients, I should say. So what is that? Well, it's 6 over 5. Okay, and I'm pulling that out of the air from this part right here. The 6 and the 5 at the beginning of this thing, those are my coefficients of the power function, the leading coefficients. So this is 6 over 5 and 6 over 5. If I were to graph it, that's where the horizontal asymptote would be. Final one. This one's a little different than the first two because on top we have some kind of an x to the sixth power, and on bottom we have some kind of an x to the fifth power. And this is called an oblique asymptote, right? Or sometimes people call it a slanted asymptote because this thing is top heavy. Okay, should have said that first. Because you have a higher exponent power on top than on bottom, this is top heavy, it produces a slanted asymptote. And what you get for this oblique or slanted asymptote is y equals the result of your long division. Now, the long division would be a little complicated to do, so I'm going to take a shortcut through that, and I'm going to say to myself, well, I know this is slanted. The question is it negative or is it positive? And if you now focus on what these numbers right here are, that's a negative 3 divided by a positive 2. So you can do long division all day long, but the end result of this is going to be some kind of a negative number, right? This is going to be some kind of y equals negative, who knows, but it's some kind of negative slanted line. Now, what does a negative slanted line look like if we were to draw a little graph right here? Something like that, okay? Which means off to the left, it's approaching infinity. And as you go to the right side, it's approaching negative infinity. That's a quick way to handle this one.